All right, here we go. 6.1.
Here we go.
All right, guys. Chapter 6 is actually just like 5th grade fractions, but now we're going to have letters, all right? So everything that you know about 5th grade fractions is still true. Like when you multiply fractions, you just multiply straight across, right? You don't have to worry about a common denominator. When you add and subtract fractions, you do got to worry about a common denominator, right? So all of that stuff that you did in 5th grade to give fractions, exactly the same. We're just going to throw in some letters.
I forgot.
Awesome. All right, so the title of this chapter is The Valley of the Shadow of Death. The word it uses is rational. We're going to have rational expressions. We're going to have rational functions. We're going to add and subtract rational stuff. We're going to multiply and divide rational stuff. What's the root word of rational? Ratio. Don't giggle because it's not rat. Ratio.
No, that's not what she said.
Oh, what did you say?
Satan.
Sorry.
This is the Satan chapter.
Ratio is just a word for what?
Fractions.
Fractions. Alright, so just the fraction chapter. We've seen some rational stuff before, like when you had to find the domain of a rational function, right? Because the domain, or the bottom can't equal 0, the denominator can't equal 0. So we've actually seen a few rational things. Okay, so what we're going to do is we're going to multiply. I don't really want to look at example 1. Example 1's lame. Let's start with example 2. That has... Well, example 1 isn't really get us into the meat and potatoes of this section. It's just like, it's lame. Alright.
Just French fries.
Example 2 says x plus 1, this one's actually going to be ridiculously easy. X plus 1 over y minus 3 times x squared over y plus 1. Is this an expression or an equation?
Expression.
It's an expression. So all we're allowed to do to it is simplify it. There's a few other things that we're allowed to do to this that I don't know if I've mentioned yet this semester. It is perfectly acceptable to add 0 to this. You don't change it if you add 0, right? It's also perfectly acceptable to multiply this by 1 because you don't change it. You're like, okay, that's stupid. Why would we do that? In like 2 sections, no, maybe even in a minute, we're going to be multiplying stuff by sneaky ones. But anyway, all right, so it's an expression.
Oh, gosh. Say, wait a minute. Don't go there.
I'm going there next. In expressions, we're not solving, we're not trying to figure out what x is, we're not trying to figure out what y is. We're just going to simplify it, right? Now, I'm nagging about this because we're going to get to rational equations in a few days, and you are going to want to suddenly take all of the easy equation rules and try to apply them to this stuff, and you're going to fail your test. Don't do that. So I will nag up until your test to try to prevent that from happening. So expressions, all you can do with them is simplify them. Do not ever delete denominators from expressions. It's not legal. Right? That's like saying 2/3, oh, I don't want it to be a fraction, it just equals 2. You can't do that, right? Not legal. Don't try to do that with these rational expressions either. Alright, so back to this. Let's do this. It just says multiply these 2 fractions together. When you multiply fractions, you just multiply straight across the numerator, straight across the denominator. You don't need common anything, you just multiply. X plus 1 times x squared is x plus 1 times x squared. Is that alright?
Wait, you're going to need to redo that. That doesn't make any sense.
Alright. X plus 1 times x squared. What's it going to be on the bottom?
Y minus y
Plus one.
times y. Do you FOIL it though?
We definitely could FOIL, and we definitely could distribute that x squared through. 99% of the time, we should not do that.
Because that's what you practiced the rest of your entire life. Don't do it now.
The reason we don't want to do that is because in a minute we're going to learn how to cancel stuff off the top and the bottom, and we can only cancel factors, which means we should leave everything factored. So if you multiply this through and FOIL it, what'd you get? You'd get like y squared minus 2y minus 3.
Yeah.
Now it is illegal to cancel stuff because you can only cancel factors, you can't cancel terms, and you've just changed this from 2 factors into 3 terms, so canceling just went out the window. So on 99% of these problems, you do not want to ever FOIL anything. I'll show you the...
That's the most simplified it could ever be, right? Is what
Correct.
you're saying? Okay.
Yeah, yeah. You want to leave everything factored so you can see if it's simplified, so you can see what cancels.
Okay.
All right.
Forget about what we learned from the previous chapter.
No, don't forget what we learned, because in the previous chapter we would take, this would be our answer, right? We'd FOIL, or we'd unfoil it and get that to be our answer. So we're going to actually do that a lot. We're going to unfoil stuff still. Okay, so this problem was ridiculously easy. We had the 2 fractions we multiplied together, no big deal.
That's what I want in the test.
Probably not going to happen. All right, we need to have a short aside about reducing fractions. They point out...
That's the answer then?
That is the answer. This is the answer.
Simplified.
They point out that if you have... And this is why I drew a frowny face and circled it, which means I didn't like it 2 years in a row. Let's actually start with this answer, this 6/10 answer. Now probably you could reduce 6/10 in your head. What does it reduce to? 3/5. The actual process for reducing this is factoring something out. Okay, there's that word factoring. What
2
factors?
times 3.
Alright, so we've got on top, a 3 times 2, and on the bottom, a 5 times 2.
And then 2's cancel each other out.
Alright, and even more nitpicky than the 2's just cancel, can't I write this as 3/5 times 2 over 2?
Yeah.
And what does 2 over 2 equal?
1.
1. So 3/5 times 1 equals 3/5.
Right.
Yeah.
Alright, so I'm hoping that with numbers you can just go straight to here
Right.
without all of that thinking in the middle. But this is actually the process we are going to be taking for scary looking algebra fractions instead of just arithmetic fractions. We're going to factor, and we're going to cancel factors. Clear back here where you wanted to cancel them, though we'll actually do that. So, canceling those. We all right with that? You guys are all right? The 6/10 and 3/5 equal the exact same number? They mean the exact same thing? All right. So what we're going to have is an algebra version of this that looks like x minus 5
Bless you.
times x plus 3 and x plus 2 times x plus 3. So these are already factored. So it's actually like we're already to this step.
So yeah, you just cross out the x plus 3's, right? Because they're the same.
Correct. And it is legal to cross these out because the top is built out of, on the biggest scale, on the most zoomed out scale, it's built out of 2 factors, right? You see this has got 2 factors? 2 factors on the bottom. If you zoom in, like if you're just looking at the x minus 5 chunk, it's built out of 2 terms. But most zoomed out, the top is built out of 2 factors. It is acceptable to cancel only when all of the top and all of the bottom is in factors. So we can cancel those out and get left with x minus 5 over x plus 2.
Does it have to be the same amount of numbers? Like, can it be 3 terms on the top and 2 on the bottom and still cancel one of them out? Okay.
Yeah, that's okay. They just
So
have
if
to
the
be
x plus
factors.
2 wasn't there, that would still work just fine. And
Yes.
the answer would be x minus 5.
Correct.
Over 1.
Over invisible 1. Yeah. Good? All right. There's like a fine print to this problem. It says, so long as x is replaced, so like if this were an equation later on, so long as x is replaced with a number other than -2 or -3, so long as that happens, then this stuff is exactly the same as this stuff. Why does it have fine print like that?
Because you can't have 0 on the bottom.
Alright, we can't have 0 on the bottom, exactly. Was there any fine print with this one? Like, 6/10 is exactly the same as 3/5, regardless of what goes on. But as soon as we get x's into the mix, there's like a fine print with every problem. So long as x is replaced with a number other than the dangerous numbers,
It doesn't blow up, I see.
so it doesn't blow up, these two are the same thing. Now what's goofy about that is that in this one, -3 doesn't look like it should be a dangerous number, right? Because that part's canceled out. It actually still is a dangerous number. If you, in 1050, when you learn how to graph this stuff, this problem actually is, you know all those graphs that have holes in them that look like this? And we've never graphed one?
Yeah.
That's what happens. When something is a dangerous number but it cancels out and totally disappears, it is not in the domain and there's a hole. Kind of weird. Just something we're going to see over the course of this chapter is that the dangerous numbers don't go away just because they go away. Alright? Keep that in mind.
So do we have to figure those out, what those numbers are? Those negative numbers, or is it, do you say it's fine print?
Yeah, we're gonna have to figure out what the domain is, what the dangerous numbers are. We're gonna have to figure that out.
But if they'd given us the x minus 5, x over, or x plus 2,
If this didn't come from this,
then there's no, not, the only dangerous number is -2. But
Correct.
if they give us something bigger on a bigger scale and we cancel stuff out, we still have to make sure that the original equation has a correct domain.
correct. That's absolutely right. Okay, so that's kind of stuff that we're not going to see for a few sections, but I'm warning you about it now so that it's not scary and new. Actually, yeah, we'll talk about that later.
That's in there.
Example 3, it's in there, it's just, now I've talked about it, I don't need to write it all out, because we'll see it for sure later. Write this function in simplified form. Alright, this is something that's important to take note of. When I was talking over here about dangerous numbers, this is the only time I'm ever going to talk about dangerous numbers when it's not a function. This was just an expression. Dangerous numbers really don't mean anything in just an expression. But as soon as we write them as a function, so like this problem, it says f of t equals 7t squared plus 21t over 14t. See the difference that this is now a function and not just an expression? Really only just because I said it's f of t equals that. As soon as it's a function, your problem must include the domain as part of your consideration. Alright? Alright with this? Okay. It says to take this function and simplify it. So the process for simplifying is doing this. Factoring it and finding factors that cancel. So look at, this is why I was saying that chapter 5 is incredibly important. You've got to be expert at the chapter 5 factoring stuff. What factors out of the top? 7t. So nothing is changing about the function. Still f of t, but I'm writing it looking different. I factor it out of 7t. What's left?
T plus 3.
T plus 3. And on the bottom I've got a 14t.
You can't use that 17 factor out of the bottom, too?
Yeah, that's the next step.
Oh.
So, I mean, I guess I don't ever write it like that, but I guess we could write it like that. Knowing that I want to cancel, isn't the bottom like 7t times 2?
Or 2, yeah.
I'm hoping that you would be able to do that step in your head even if you left it as a 14t, but this is what it looks like. Now let me ask you, is it legal to cancel stuff the way this is written?
Yes, because it's 7t equals 1.
It is legal to cancel not because 7t equals anything, but because the top, on the most zoomed out scale, is built out of 3 factors. On the most zoomed out scale on the bottom, we've got factors. There's no pluses or minuses. And some people are like, there's a plus on the top, but it's nested within a factor, right? You are only allowed to cancel when stuff is entirely factored. Not when there's pluses or minuses. If you have something on the top that looks like this, no canceling. This is term. 2 terms up here. Factors have multiplying in between. Alright, so it's legal to cancel. What cancels?
17.
7's are gone, t's are gone. So our simplified function is f of t equals t plus 3
over 2.
over 2. Now we've got a problem. Are there any dangerous numbers in this version?
Not in that one.
Not in this one.
In
But
the
above
original.
one it is.
In this original one, and I'm going to specifically say right before we canceled, what was the dangerous number?
0.
0.
If t equaled 0, you'd get 7 times 0 times 2, or up here 14 times 0. You get a 0 in the denominator, right? So 0 is the dangerous number. And what I was nagging about just a second ago, if you cancel away something that's a dangerous number, it doesn't go away. It's going to still be a hole in your function. So at the end of your function, this is the way that the notation for this, which is really nice. We don't have to use major domain notation. You can just make a little note, comma, t does not equal 0. Even though 0 looks like it would be safe in that version, it's not. Yeah.
Wait, so how'd you get the dangerous number in there?
I guess if you follow the math that we used to do, you take the denominator, which we'll just do the
And like
14.
set it to 0.
Set it equal to 0, so divide both sides by 14, get t equals 0. Yeah,
And you said we only have to write that if it's a function.
correct. Yeah, okay, so that's a good point. When these are function problems, which are going to be about half the time now, you must include the domain. Just get used to it. If they are expression problems where there's no f of anything, we don't got to worry about domain. Most of the time, because these are going to get more complicated and have y's and stuff, and it's not going to make any sense to even talk about domain. But if they are functions, you must write that domain. All right. So this next problem, example 4. It's another function problem. Says, write the function given by this function in simplified form and list all restrictions on the domain. So the function is g of x equals x squared plus 3x minus 10 all over 2x squared minus 3x minus 2. So the instruction said, write it in simplified form and list the restrictions on the domain. So I've got 2 questions for you. First of all, can you tell me what the dangerous numbers are right now just by looking at it?
Negative, and plus 2.
No, you can't.
Just by looking at it right now? No. Is it legal, my second question for you, is it legal to cancel, like, say, those x squareds and those 3x's?
No.
No, why not?
They're not in n factored term or whatever. They're not.
Correct. They are terms, not factors. So on the most zoomed out scale, how many terms are up here? There's 3 terms up here. How many terms down here? 3 terms.
It's hard though. You see, remember we did polynomials and you'll cross one out to help solve for x, but you can't do that again.
No, that's not going to be legal here. So because there are any terms, not because there's 3, because there are any terms, canceling is illegal right now. It has to be 100% in factors before you can cancel anything. So we need to factor this. So on the top,
Plus 5 x minus 2.
x plus 5 and x minus 2. Everyone agree with that?
Yes.
And it was eligible for the shortcut, so we can just go straight to that.
Yes.
So we haven't done any, we haven't changed it. We've changed how it looks, but this still means the same thing. X plus 5 and x minus 2. If we FOILed it out, we'd get back to x squared plus 3x minus 10. So we factored that. So now on the most zoomed out scale, the top is built out of what? 2 what?
2 equations. Well, 2
2 factors is the word I'm fishing for.
factors.
2 factors on its most zoomed out scale. We need to do the same thing for the bottom, but it's going to be a little more complicated. So out to the side of the problem, let's take this 2x squared minus 3x minus 2. How are we gonna factor that?
Have to take two
Negative
times
two
two is
times two.
negative
So
4.
1 and 4, and negative 4 and 1.
-4, +1, and we can't just go straight to x minus 4, x plus 1, right?
No, but you're trying to get rid of them, so you want it to be either a 2. You want it to be a 2.
We gotta do the grouping thing.
Yeah.
2x squared minus 4x plus 1x minus 2.
Yeah.
Alright, so I'm gonna group them. Grouped over a plus, so that was alright. What comes out of the first group?
2x plus 1.
2x leaves us with x minus 2. Oh, have we run into this before where nothing comes out?
Just pull a 1.
So it's like we pulled an invisible 1 out. So we're gonna have x minus 2 times 2x plus 1. Alright, so we just factored this. This is now what's on the bottom. X minus 2, 2x plus 1.
Now figure out the domain was there, right?
Right now, correct. Right now is when you figure out the domain, because the next step is going to be canceling. You should figure out the domain after you factored, but before you cancel. That's when you should look at the domain.
So it's positive 2 and negative 1.
After factoring, positive 2 is right, negative 1 is not quite right.
Negative 1 half.
Oh, yeah. Negative.
After factoring, before canceling. That's when you should figure out the domain. So, is the long process for figuring out the domain is to take the denominator and set it equal to 0. So we've got this denominator of x minus 2 and 2x plus 1, and if we set it equal to 0, either the first chunk equals 0 or the second chunk equals 0, and from this one we get x equals 2, and from this one
Negative 1 half.
Negative 1.
x equals negative 1/2. If you need to write this, that's fine, but you're going to start doing this so often, and especially if you're going on to 1050, you need to get to the point, you don't need to, but it'd be really nice for you if you got to the point where you could just look at this and figure out the dangerous number for this piece is 2, and the dangerous number for this piece, you'd have to subtract 1, so it'd be negative 1/2. So those are the dangerous numbers that come from those two factors. Now, what can we cancel?
X minus 2.
X minus 2 chunk cancels on the top and the bottom. So the simplified version of this function is g of x equals, what's on the top?
X plus 5.
X plus 5,
2x plus 1.
2x plus 1, and they just say, comma, x cannot equal
Not equal
2 and negative 1.
2 and negative 1/2. Even though the 2 stuff canceled away, it's still one of the dangerous numbers. The book is going to write this answer without parentheses. Without parentheses, I said. I don't care if you write it without parentheses, but leaving stuff in its parentheses will help you not accidentally cancel illegal stuff. Some people are going to be really tempted to cancel these x's. Why is that not okay?
because they're part of a problem.
They're part of they're terms.
They're part of the term.
Yeah, so this is terms with the 5, but it's one big chunk. So if you're going to cancel out this x, it darn well better go with the x plus 5. There's no x plus 5 to cancel it out with. So don't cancel those x's. If you are confident enough in your ability to not cancel out extra x's, you can write it like this. But if you leave it in parentheses, it's just like a little safety guard. All right. Now, example 5 says simplify. We've got 9x squared plus 6xy minus 3y squared all over 12x squared minus 12y squared. Do we need to worry about domain on this problem? No,
No
it's not a function. I mean, it's got x's and y's, so it wouldn't really make sense to figure out what makes it equal 0, because we'd have to have two numbers. It doesn't work. So don't worry about domain. All we need to do is simplify this.
Pull out a 3.
Pull out a 3. Okay, so guys, what boils down to is that you need to run this through that filter that we ran stuff through last time. See if something comes out of everything. Count the terms. Check and see if it's a perfect square trinomial. Check and see if it's a difference of squares. Check and see if it's a sum of cubes. Like, this is chapter 5, but 2 problems rolled into one, sometimes more than 2. So on the top, you guys said let's pull out a 3. Anything else come out?
What up, 3 at the top and the bottom?
A 3 on the top and the bottom? Something
Bottom
bigger
you
than 3
can pull
coming
out
out.
12 though.
Alright, so on the top, if we pull out a 3, we get
3x squared plus
Minus y squared.
Alright, and on the bottom, pull out a 12.
And x plus 1, x minus 1.
Alright, we'll get to that one next up. You're right, that's the difference of squares, that's what it turns into. Question, right now, is it legal to cancel?
Yes.
The 3
The
and the
3 and
12, yes,
12.
because they're out of the parentheses and they're the same term, right?
Alright, so
It'd be 1/4.
you're right, that reduces to 1/4. And it is legal to do that because on the most zoomed out scale,